So what you see on your screen, okay, you see some numbers, right? Now these are about 200, okay, and this is data taken from so randomly selected by a telephone company's marketing manager. Okay, so what they did, they randomly selected data from their uh, customers who make long distance calls. Okay, and this is their bill for long distance. Okay, and they just captured this. Okay, now by looking at it, what can you say? How can you analyze this data? There's 200 numbers you see. What can you say? How do you analyze this?
It's a decimal numbers.
So what? So how does that help you in analysis? So when you have, just raw data, nothing else, at max you can talk about the minimum and maximum. You can see, okay, minimum the call is about $0 here, right? So that means there are customers who have made $0, no outgoing calls, no international calls. Okay. Then there are like highest is $119.63, right? So the numbers vary from $0 to $120. That's all you know. Okay. Probably you won't be able to perform much. So we have to kind of summarize this data in a way which helps us to get more analysis. Okay. So in such cases, histogram is very helpful. Okay. Now in scatter plot, you have XY, two variables. Okay. One that you plot on X axis, one that you plot on Y axis. In this case, these are your single numbers, right? These are not two variables. This is one variable, right? Telephone bill, one variable. This is one variable problem. Okay, so obviously you cannot make scatter plot. So in this case, we use histogram. Okay, and if you let's go to the next slide. Okay, so histogram is like a bar graph. What you see here is a bar graph, and on y-axis you put the number of count. Okay, on x-axis is the range. Okay, so if you have like one number, is the range here on the x-axis. So starts from 0, goes way all the way up to 120, right? And height represents the number of values within that range. So number of buckets or bins we call them. So each bar is called as bins. Number of bins, or we also call it as bucket. Now this bin, okay, the way histogram is created, that bin number of bin should not be less than 8. Okay. Now this is just guidelines. Okay. Should not be less than 8, because less than 8 you have too few data and you won't be able to make more sense out of it. You should not make more than 12 also. More than 12 means you have too many data. Okay. Then again it will be difficult to analyze. Okay. So 8 to 12, around 10 bins is good enough. So now you have data from 0 to 120. Okay. So what should be the range, okay, to have a proper bin, right? So you can create, this is the, okay, formula, okay. So if you do, number of classes, and I'm going to explain you this way, okay, forget about this. Now, if you create, so range you can make from like 0 to 10, 10 to 20, 20 to 30, right? Or you can have, so you have option to make range 0 to 10, 10 to 20. Okay. Now, if you do like that, how many bins will we get? How many classes or bins will we get? 0 to 10, 10 to 20, 20 to 30, from 0 to 120? 120 by 10. Okay, total number is 120, 20 by range 10. So you get around 12 bins. If you do 0 to 15, okay, 0 to 15, 15 to 30, okay, 30 to 45, so on, up to 120, you get about 8 bins, right? Then you have choice of doing 0 to 20 also. 0 to 20, 20 to 40, okay, 40 to 60, so on up to 120. You get 120 by 20, which is about
6 bins.
6 bins, right? So this is too less, and maybe this is too much. Okay, so this is our preferred. Okay, now this as soon I told you that statistics will only make you suggestions. Okay, it's ultimately up to you what you do, right? You can also take 0 to 10, not a problem, right? But definitely not 0 to 20. It is too less. 6 is too less. Okay, okay, so you can take 0 to 10 also. Okay, okay. So this is the size that you have decided. Okay, so I'm going to create pins of size 0 to 10. Now you create what is called as frequency table. This is called frequency table. Okay, frequency, you see, frequency table. So frequency table gives us the frequency of the data. That means between 0 to 15, how many data points are there? So you go back and you count 0 to 15. Okay, 1, okay, 2 here, 3 here, 4, right? You have to count. And this is where your Python skill will be helpful. Okay, you should be able to count using Python. Okay, so you have,
At down 11 point. Yeah.
yeah, we can't count 71, right? So just go
Okay.
give you some sample. So you have to
Okay.
count, and this is where your programming skill will come. Okay, you should be able to count number of values between um, 0 and 15. Okay, so you say 71, then 15 to 30. Okay, you get this number. Now you draw a bar graph. So bar graph that you draw from frequency table is called histogram. This is histogram. Okay, this is histogram. And this is a bar graph where on y-axis you have count, okay, number of frequency. It's always frequency is the number of occurrences. And you have the range. So 0 to 15, 15 to 30, 30 to 45, 45 to 60, okay, up to 120, right? So you have drawn this. Okay, this is what you get. Now you tell me, what do you analyze from this? What do you get from this?
I mean, it's easy to analyze it, like I seen the graph. Yeah.
Hmm. Sorry, you said something I didn't hear.
And like it will be easy to analyze like this, not like
Yeah. So
looking.
now tell me, what is your analysis?
If you see like the when so the can I talk?
Of, of course, it's for everyone.
So below 15 or 0 to 15, the money bills who got under 15, there's a 71 members are there, the list.
Yeah, one
And
person at a
who
time.
got,
Yeah. Yeah.
I'm saying like 50, under 15, these bills are like 71 members got rupees 15, like bills
Mm-hmm.
under 15. And 37 members got like 15 to 30 range got of bills from 15 rupees to 30 rupees.
Okay. So
The frequency of
you are telling me
frequency.
what is there. I'm telling you what does it tell? What is the analysis that you make? This we already know, right? This we created. So you don't have to tell me that 0 to 15 we have 71, right? But how do you perceive the whole data set? You are repeating what you did, right? But what does it tell you?
That's what it tells. I mean,
Now to tell that,
depending
why
on
did
the
you draw
data,
histogram?
we are plotting like while
Plotting,
taking x-axis and
yeah,
y-axis.
plotting is not, plotting does not make sense for the business, right? Okay. It is what
Generally,
knowledge.
people generally, can I talk?
Of course, you
Yes,
can.
yes, you can. I mean, most of the people are getting bill to 0 to 15. Most of them are getting bill
Okay.
range of 0 to
Okay.
15.
Okay. Good point. One third is getting that. So, what
Mm.
does that tell you? What does that help you?
We can like see like estimation uh, where the range is getting more and where the people are using less kind. What
No.
does that tell means? I mean, accordingly, the business can plan.
What plan can you
To,
do?
I mean, depending on that graph, they can make plans, right? Like, okay,
The graph
people
is
are
front of
getting,
you, no. Graph is given
yeah.
to you. So what plan can you make?
And with that 0 to 15 sound on numbers, right? Most probably are preferring like less than 15.
So if you look at the data set, right, you see that, okay, almost half of the people, their bill is between 0 to 30, right? So if you look at this histogram, you can divide this whole data set into three groups, right? You can divide this data set into three groups. Okay, so first group is where, people, so there are like 108 out of 200, right? So more than 50% people, their bills are small. So you can say this is small size or small bill group, small group. Then you have
I mean,
second
like
group.
more people are there, but bills are very less.
Correct. So this is your small bills group. Now,
Okay.
if you divide this again, like see, so on the rightmost side again, you have more people, around 30%. So here you have about 50%. Okay. Here you have about 30%. But there are very few people with, okay, very few people with bill between 30 and 75, which is your middle group. Okay. So this is small group. This is your high bill group, and this is your middle group, right? So now you have divided this data into three parts. So instead of looking at 200 numbers, now you're looking at only three numbers, right? Small, medium, and high. Okay. So this is the, you see, okay, the more 30% people are having a high bill, 50% people are having a very low bill, and maybe around 15 to 20% is having medium sized bill. And also if you see the range is high here, right? Here range is less. Range is 0 to 30, 30 only. Here it is 90 to 120, 30 only, right? And here also you have about, so this is 45. So 30 to 75. 30 to 75 is 40. No, 30 to 75 is 45. So here you have only 30. No, this is also 45. Sorry. This is also 45, right? This is also 45. Okay. So the range is $45, $45 and $30. Okay. So you have most of the people, okay, in your on in your left side, okay, which is high volume group. No, low bill group. So now you understood this. Now how do you extend it? What action will you take? So you have analyzed it. Okay, this is what data analysis will tell you. When you say data analysis, this is what data analysis will tell you. You know, draw a histogram, you get this. Now, what do you make sense? How do you understand from it? See, after this, we are getting into visualization, right? So I'm only going to draw the visualization. I'm going to show you how to draw histogram, bar graph, scatter plot. We're not going to discuss in all details, right? So that's why I'm saying this thing is important. Use, try to, um, it's more about, see, I'm not expecting you to get it right? I'm not expecting you to be correct when you speak, but I want you to think, I want you to speak, I want you to speak something. Doesn't
Mhm.
matter if it is wrong or irrelevant. You should start thinking. Yeah,
So the
that's okay.
company might target on the people who are getting more bills, so
Mm-hmm.
that they can attract them to stick to their brand or company.
Mm-hmm.
They can offer some. kind of discounts after, I mean, if they, take those more than they, what, if they spend more time on the call for more than 2 to 3 hours, they can get a discount or something like that.
Correct. So see, so what happens is, okay, the action that you take will depend upon the industry you're working with. Okay.
Yeah.
So now if you think that this is a retail industry, okay, and you're looking at the um, bucket size or called basket size. Basket size is the, when they come, like how much money they spend with you, right? When they come to your store. So for retailers, okay, this would be, kind of concern that most of people are spending less money. Okay. So you want to give them offer, buy one, get one free. Okay. You buy this, get discount on that. Why are they giving is they want you to increase your basket size. They want to move these set of people at least to the middle level so that you get people who doesn't come, that's fine, but who comes to you to buy, they buy bigger size. Okay. Okay, that's how they make money. Retailers, that's how they make money, right? If you buy more from them only, they'll make money. So retailers would start thinking, okay, half my customers is buying less than $30 per visit. So how do I make them buy more? What offer can I give them? I want them to buy more. Okay. So they will try to push these people to this group. Okay. Now, if you talk about telecom, it's reverse. See, now if you look at any telecom providers, they're all same. There's not, if if some if you can say that all of them are equally good or all of them equally bad, right? They don't provide any kind of advantage, right? So what they try to do is they try to get more customer. For them, getting more customer is important. But tomorrow, if you realize that you are paying more on this provider, whatever provider you have, and if you switch to different provider, your bill is going to reduce by 20%, 30%. Will you not switch? You will switch, right? Because there's nothing a provider can give you, right? In telecom industry, it's all about the money, okay? They play on the money, okay? So in this case, see retailers, okay, their aim would be to move this low value to middle value to high value. But for telecom provider, it's reverse because these are the people who are at the risk. Okay, these people they pay high money. That means they're at a risk. Tomorrow, if these people realize that if they switch to competitor, okay, their bill will be reduced to 20%. Whatever they're paying, like 120% who is paying $120, they'll be start paying under $200, under $100, right? So these are the people who are at risk of losing. You can lose them. Moment, okay, a company comes up with some different plan for international calling, 20% or 30% of people will lose. You're going to lose. 30% customer is too big number. It's a concern. How can you help them to come to the at least middle part? Okay, so that's why when you try to recharge or when you go for your option, right? These companies will have many options. They want to give something for everyone. If you want to use internet for one day or for 1 year, you want to make calls, you want to listen to music, whatever. So they have different plans for everyone because they want to target everybody. Okay, they cannot leave out one section of people. If these people who has a high international calling um, amount, okay, and if you do not have something for them, they will move to another provider who you will give them better rates, right? So for telecom provider, these are the people they should target and make them somehow move to this. Okay. So earlier, I'm telling you about 10 years, 15 years back, I was on Airtel and they used to every month along with the bill, they'll send you an option. If you change your plan from XYZ to ABC, you're going to save 10%. Okay. So they would analyze and tell that, probably this plan is right for you, not this plan. because they want you to stick with them. They want you to spend less. Okay, because if you if you get that feeling that I'm spending less using this plan or this provider, your your loyalty will be high. Okay, so in telecom, it's the loyalty is based on amount only. If they start charging you more, you will quickly switch. Doesn't take time to switch, right? So they would start talking about, because these are the target for your competitor. Now, if this is known a competitor, they will start sending messages to these people saying that, come to us and you can reduce your bill by 30% or 20%. Okay. So company needs to know more about these customers, and with additional information, the marketing manager may suggest an alteration of its pricing so that their bill is reduced and they stick with this company for long. Right? So that's where the domain knowledge, okay, business knowledge is also important. Okay. What is good news for retail may be bad news for telecom. Right? In telecom, they want you to spend less with them so that you stick to them. Okay, they make money based on the customer base. Okay, they want to acquire more and more customer. That's it. Retailer, they want you to spend more with them. That's why they give you discount offers and things like that. Okay. Okay. Any question? Any question on this?
No. No, sir. No.
Okay. So now we'll talk about statistics. Okay. Let me share my screen again. Okay. So when you talk about statistics, okay, there are three basic statistics. Those are mean, median, mode. What is mean, median, mode, and what does they tell you? Mean is simply the average of all the values.
Average.
Right? Yes. So if you have n numbers, you add all of them and divide by n, total number. Median is the mid value. Okay. So that means, okay, if you have, let's say, values, numbers, 50 numbers. So first thing is that you need to arrange in increasing order. Okay. For mean, the order doesn't matter, right? You need to add them all and then you divide by n and you get average. Median is about mid value, right? So you find the mid value of the numbers. So if you have 50, you arrange them in increasing order and then look for 50. So here, if you see in this example, how many values are there? Okay, this is the median, right? Now, if you see first example here, you can see my cursor moving, right?
Yeah.
Now, if you look at this data set, here you have 4 plus 4 plus 1, 9 numbers. Odd number, okay? In odd number, 21 divides the data set into two halves, isn't it? So you have 4 on the left, 4 on the right. So 21 is middle, exact middle. So median of this data set is 21. Median of this data set is 21. Now, if you come to this data set, here you have got 10 numbers. Now, in 10 numbers, you cannot have one median because you can't have one value dividing into equal halves, right? So if you take one number, one side it will be 4, other side it will be 5. So in that case, you have to take two values at middle, right? So here you have, you take 21 and 44, two numbers as midpoint. So median will be 21, 20, 44, so that, now you have equal numbers on both the sides. So when you have odd number of data set, okay, it is one number that will divide the data, right? But when you have even numbers of data set, there will be two numbers together, they divide. So when you have two numbers, then you take the mean of these two numbers. So in this case, median is average of 21 and 44, which is 33 or 32.5. No. Correct? Why did I say 43? It's not mean. 40, 60. Yeah, I don't know how did I. Okay, mean is because of the total, right? Mean is the entire total. Okay. So if you add them all, yeah, add them all and divide by 10, you get 43.4. And median in this case is, average of 21 and 44, which is
44.
65
by 2.
by 2,
By 2, 35 points.
32.5. Okay. So this is how I calculate median. Now, mode is the maximum occurring value. Okay.
Repetition. Yes.
Yes, which has the maximum repetition. Now, okay, so if you have discrete values, here's discrete value, okay, you will get, you see here in this data set, it's 5 is the mode, right? Now, when you have continuous, like telephone bill, we had continuous, we had decimal values, lot of values, right? So in that case, we take range, okay? So do you remember, like in the last example that we did, what could have been the mode?
$71.
No.
0 to 50.
Correct. 71 is the count. Correct. So 0 to 15. Yes. So 0 to 15 was the mode of previous example because that had the maximum value, isn't it? So 0 to 15 was the mode. Exactly. So the one that gives you maximum value. So, okay. So when you have continuous values, okay, we take range, right? In histogram, the which has the longest, highest bar. Okay. The biggest bar is your mode. Okay. So this is median mode. These are basic statistics. Now, what is the advantage or not the advantage? What is the significance of this? What does it tell you? What does mean tell you?
Mean tells the average.
Of course, but what does it tell you? The sense, what message does it give to you? Mean gives you average, median gives you mid value, but what are the message they are trying to convey to you?
From mode, we can know maximum number. I mean, what maximum people are wanting.
Okay.
And from average is like you're covering every group of people. That's the common thing. If you go, if you pick a plan or
So see, these numbers, okay, are one single number that can describe your activity, okay, or describe your data set. Okay, if I ask you, what is your 10th class marks? Okay, so you'll not say me, okay, in English I got this, in Hindi I got this, in maths I got this, science I got. You will say, okay, I got an average of 80%. So it's a number that describes the entire data set. If I ask you, okay, you'll say that, okay, I do morning walk. If I ask you, how many miles do you go for walk? You won't say, first of the month I went for 5 miles, and second I did not get time, I did only half mile, third I did 10 miles, second day I did 2 miles, third day I did, fourth day I did. You don't tell me the story. You'll say, on average, I do 5 miles per day. Right? So it is a number, okay? It is a number that describes the entire data set, right? So you don't start telling each and every day stuff, right? Here you have 9 numbers or 10 numbers. Don't start telling about that, okay? So if they want in detail, of course you can say that on Sundays so you can get into again days. On Sunday my average is higher. On Wednesdays my average is lower, right? You can talk about those things. But okay, mean and median, okay, they are to represent the entire data set. One number will represent entire data set. So if you take this data set here, if you see my cursor, mean says that, okay, this data has an average of 43.4, okay, and median, okay, will also represent that. But which one to select, mean or median? Both I'm saying is one that represents the single value, right? Now in this case, is it 43.4 or 32.5? Okay, so let me give you with an example. Okay, Okay, so let's say I take take some sample numbers. So I'm going to start with, let's say, 40, 45, 45, 50, 50, 50, 55, 55, 60. Okay, so let's say I have these numbers with me. Okay, let me make them bold and center. Okay, now what is the average of these values? Average or mean, right? We talk about mean, not average. Okay, so average is average of this. Excel will give us the average, right? You can manually add them or divide or directly say average. So average, so mean here is 50, right? Now what is median? Okay, so we'll find median and we'll find mode. Okay, so we have how many data set? So if you look at
9.
this, right, 9, correct? So 50 is dividing into halves. So median is
50.
50. What is
Mode
mode?
is also 50.
Mode is also 50. Okay. Now, if you take a normal data, this is how you'll have normal data. Now, if you talk about any data, for example, okay, you'll have very few people with less marks, very few people with very high marks. Most of the people will be around average mark. That's why so when you talk about height, for example, you'll find very few people in short height, very few people with very long height. Okay, most of people will be around average, right? So in nature, okay, and the way, if you take large numbers, this is what you will see generally. You will see that the numbers, okay, will be very few less numbers, very few more numbers, most values around middle. So in this case, your mean, median, mode all are same. So if your number is normal, okay, your data mean, median, mode will all show you same value approximately, okay, approximately same. It could be 49, 50, 58, something like that. This is what happens when you take and lot of population, a lot of data, okay. But problem comes when you start getting some outliers. I told you yesterday also the word average thing, right? Okay. Yeah, okay. Now if you talk about, let's say you take scores, average scores by all the openers in test match of all the countries, okay, you will see something like this. Okay, the best opener will have high value there, um, uh, but most of the values will be around, okay, average, right? That's why we call it average. Okay, you score high on one match, okay, and you score low on one match. Very few times, okay, batsmen, okay, will get out on zero. Very few times they're going to hit centuries. Most of the time they're going to hit around this number only, right? So normal circumstances, you see, all three values are same. Okay, problem comes, okay, not problems, but things starts changing when you have an outliers. Okay, let me move this to, let's say you got extra, let's say you get 3 new values. Okay, now 60, right? Now let's say we get 150, okay, 200, okay, you get 500. Okay, now you see in this case, okay, our mean has become 108, correct? And what happens to median? So now we added 9 plus 3, 12, right? So 12 means, let me change this color. So these two, right? No, sorry.
50 and 55.
50 and 55, right? Okay, so you have 5 data on the left and 5 on the right. Okay. So what is median in this case? 52.5. Okay. Mode is not affected. Outliers will not come in bulk. Mode is not affected. Mode will remain same. Median increased but slightly, very less, almost negligible change. And mean, okay, it starts running, right? It just, okay, just one extra, one outlier, and mean runs like crazy. So what happens? What do you see? Mode is not impacted. Mode does not care about if you add some outlier, some values. Outliers will always be one, I mean, very less, right? It will not be as big as some of the regular values. So mode is absolutely not impacted. Okay. So that's why we don't generally use mode. Okay. Very few places we talk about mode. Mode does not tell you good picture. Mode only tells you, okay, what is the maximum occurring value? That's it. But not more than that. You don't know how many values, or, or what is the, it's like, if they, if, mode is like, it's like, as you all said, right? It's about telling you which number is occurring maximum, right? But it doesn't tell you anything about the whole data set, correct? So yeah, it's a good metric, but not very useful, not as useful as average or mean. So now when we talk about median, okay, see, when the data set is normal, okay, when you do not have outliers on either side, outliers can be left side also. You can add -100 also. Can you go on mute, Bindu? Okay. So you can have values on the lower side also, okay, not only higher side. So then mean will go extreme left, right? So, so when your data is normal, mean and median both can be used. Doesn't matter. Okay, both. Maybe there's a small change. Okay, it could be 50 and that could be 52. Doesn't matter. Okay, you can use either of them. So when data does not have outliers, we tend to use mean. Okay, so mean is used. But when your data can have outliers, okay, we should use median, not mean. Okay. Let's say there's one cricket player, he scored 5 runs, 5 runs, 5 runs, 5 runs, 5 runs, and then scores, double century. Okay. So now average, if you look at, average will be good average. Average will be good only. Okay. 44, which is good, right? But median will give you only 5. 5 is the median, right? So in a way, this describes his actual performance, not mean. Correct? Because just because you scored one match 200 doesn't mean that you should be in the team forever. Correct or not? But most of the time he's not able to play. Right? That's what it says. So median has advantage of removing the outliers. Okay. So when you have very large value and you're not sure whether it will have outliers, we prefer mean. Mean, so when you have outliers, mean will also change, median will also change. Both will change in the same direction. Okay, if you add high value on the right side, on the higher side, both mean and median will go right side. But mean will go too much on the right. Median will move slightly. Correct? Okay, so that's the significance of mean and median. Mean and median both are used to represent the data set. Okay, but mean is not good metric when you have outliers, because mean can give you wrong perception, wrong information about the data set. Median is preferred because it ignores the outliers. It ignores. It's like, okay, you have scored 200. It is just one more inning. Okay, I'm going to move little bit towards right, not coming running to you. Mean will say I'm running to you, right? Just because you scored high in one match, or you scored less in one match. Okay, it's not going to impact median by much, right? So that's why we sometimes, to gauge someone's performance, we prefer to use median, not mean. Okay, this happens in B schools, right? In India, let's say 90%, okay, uh, students get placed in Indian companies, and 10% gets foreign placement, and foreign placement obviously, will be much higher than Indian placement. Okay, so let's say Indian placement average salary is 5 lakhs, 6 lakhs, 5 lakhs, 6 lakhs, and 150 lakh US placement will change the average. Okay, the company will start saying average placement 20 lakhs, but only 1 or 2% have got more than 20 lakhs. In this case, if you see, right, we say average 108, but out of 12, only 3 has more than average. This is what happens, right? These are your Indian placements and this is foreign placement. So in this case, median will give you good picture, okay, that yes, even though you have few high values, no doubt, okay, that so again, sometimes in some analysis, we prefer to use both mean and median. If mean and median are in same range, then you know that data is normal and pretty much you can depend on the data. But if they are different, okay, then you have to dig deeper. In this case, there is so much of difference between median and mean. That means you have to dig into the data. Okay, you have to understand why there is so much of difference. But let's say if mean was 60 and median was 50, let's say. So in this case, probably, you can go either with mean or median, doesn't matter. It's not going to change your analysis by much. Okay. But if difference is too high, let's say 90 and 50, then you have to go and see what happened in the data. Yes. So that's how mean, median are important, both, right? Both perform, job is same. Both will tell you same thing. Okay. But the context is very different. Yes.
Okay.
Yes.
So
Yes,
here
Bhakti.
there are only like 5 or 9 observations. So we are easily saying uh,
No, doesn't matter. If you have 1,000 also, it's the same thing.
no. What I'm saying is if
Mhm.
correctly in the mean only the number is less, but to the left and the right, both the numbers are more, then it would be wrong to take the median as well, right?
No, so you're saying that you're adding here minus 100
No,
and
not minus 100.
mhm.
Let's take this score 5, 5.
Huh.
So let it be here 55, here 75, and exactly in the middle, it's 5 or it's duck out.
See, you forgot the first statement. What did I say for the median? You were sleeping when I spoke about that.
No.
You should arrange the numbers in increasing order.
Shit.
That's the first statement about median.
Oh, wait. Sorry.
Yes, in ascending order you said like.
Yes. So
In
median,
ascending order.
okay, median is always you have to put the numbers in the ascending order. Okay, or descending order, doesn't matter. You can put in descending order also, ascending order also. Mostly we put ascending order. It has to be in order. It's not about, okay, mid value in the sense, actual mid value. You have to put it in the increasing order always.
Okay.
Okay. Yes. So just a second, we'll move back to our notes. Okay, so this is what median will tell you. Now let's see here. You see, there are data from two schools. Okay, school A and school B. So you have mean, median, and mode. You see down. Now, what do you understand from this? Does this tell you anything? So see here, mode
So
7. Yeah.
mean is near only, but when compared to median, there is much difference like compared to school and school.
Right. So mean is very much similar, but median is high here, and
In school
mode,
is
yes, and mode is low. So it tells you that bulk of the values are on the lower side. That's why median is less. Median is less means bulk of the values are on the lower side. Most of the students have scored less, very less mark. Okay. There are few students who have scored high, because of which your average is going up. Right? So there is a lot of difference between marks in school B. And school A is See, all mean, median, mode are all in same range, right? So, so that means here all the students have scored kind of normal marks, but here there are a lot of differences, so that's what you can see from the data also. Okay, so in a way, depending upon how you look at it, school B can be better. Okay, because you have people who scoring 99, 100 also. That's why you see mode is 99. Okay, or if you want to be average, maybe school A is better. Most of the students are getting, so it's very predictable. See, when you are predictable, that means school effort is there. Now, if the numbers are not in the same range, that means the school does not have much role to play, right? Because if I'm talking about same concept, one of you understood and one does not understand, that means maybe my explanation is not good. Okay, maybe the one person who understood is because of his or her expertise or IQ. But if all of you understood in same fashion, that means whether good or bad, I've been able to explain the concept to you, right? So something similar. Okay, maybe these students are not capable enough. School did not help them to do well. These students are brilliant. That's how they were able to do it. Here you can say that school effort is seen, because you can't have 20 students getting almost same marks, right? So this is the actual school where the effort has been given. Now interpretation is all up to you. Okay, numbers will tell you, and how you interpret is up to you. Okay, so we'll stop here. Any questions